Hi everyone, it's Ms. Chen. I'm here to provide a short video tutorial for number 2 in the potential energy diagram practice. This is the first section of your day 35 classwork assignment. The purpose of the first half is to review what you did in the day 34 classwork assignment, where we started to analyze these potential energy diagrams in more depth. And just to remind you, these are ways to visualize the energy changes that occur in both exothermic and endothermic chemical reactions. It's basically just a way for us to track the changes that happen while a reaction progresses from reactants to products. So here we go. Number 1, I want you to try on your own, and then I'm going to go over number 2 right now. So let me go over to this tab here. In number 2, I wanted you to draw your own potential energy diagram using the following data. Remember, my abbreviation for potential energy is capital P, capital E. Okay, so part of my given information is that we know the potential energy of your reactants is 50 kilojoules, and we know that after the reaction's done, the potential energy of the products will be 10 kilojoules. And remember, this symbol EA stands for activation energy, and that tells us how much additional energy the reactants need to be able to break their bonds before they start to rearrange and form new bonds and turn into products. So this is going to help us to figure out the peak of our graph. So here we go. Before we start, make sure that you're labeling the x and y axis of your graph. So our x-axis is not going to have any numbers. We're just going to call it reaction progress. So I abbreviate reaction with RXN. That's what that stands for. Reaction progress. This is kind of just like talking about basically the time. So as the graph goes from left to right, we're going to assume that time has passed. And so that's why we're going to draw the reactants furthest to the left side of the graph, and we're going to draw the products furthest to the right side of the graph. But on your y-axis, I want you to label it PE for potential energy. And based off of our given information, we can see that the units of energy for this graph are going to be kilojoules. So it's good practice to put the units in parentheses. Now we have to figure out an appropriate scale. So we can see that we're going to need to start our graph off at 50 kilojoules. Our graph is going to end at 10 kilojoules. And remember, this activation energy is going to give us a clue as to where our peak will be. So this is the additional energy that the reactants need to be able to break their bonds and rearrange. So 50 plus 30 tells us that the peak of our graph will be at 80. So I'm going to propose that we go by tens. So I'm going to make every box worth 10. So 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay, so that should give us enough room to draw our graph. So we're going to start off with a straight line. You can make it like 2 or 3 boxes wide. It really doesn't matter, but it needs to be even with 50 kilojoules. So we're going to draw as straight of a line as we can here, and we'll call that representative of the reactants. Okay, and then we know that by the end of the reaction, the potential energy of our products will be at 10 kilojoules. So 10 kilojoules will be even here. So these last 3 boxes here, I'm going to draw a line right here at the 10 kilojoule mark, and I'm going to call that representative of the products. Now the middle of the graph is going to involve a peak, and that peak is going to reach 50 plus 30, which is 80, because remember, this activation energy EA represents the additional energy that the reactants need to break their bonds and rearrange to turn into the product. So right at about the 80 mark, right up there, I'm going to have to make sure the peak of the graph touches. So we're going to go up to 80, make kind of like a smooth curve. Why did my pen pause? Whoa, whoa, whoa. Okay, sorry, kind of spaz there. Try this again. We'll go up to 80, make that a smooth curve, and then come down and connect to where the products end. Okay, so that's a pretty good graph for our potential energy diagram. And then now for this part, when we want to calculate the delta H for the reaction, remember delta H, the delta means that there's a change in enthalpy. So essentially, to calculate the change in enthalpy, remember, enthalpy is just a fancy word in this case for potential energy. So to find the change in potential energy for the reaction, we're going to need to take the potential energy of the products and minus the potential energy of the reactants. So what that would look like is we would take 10 kilojoules and we would subtract 50 kilojoules, and this would give us negative 40 kilojoules as our change in enthalpy for the reaction. So I'm going to make that a little bit bigger so you can see. Okay. And just to draw in on the graph so you can visually see it. So the difference between the potential energy of the reactants and the products, so this area from here to here, that difference would represent the delta H of the graph. Okay, and then let me just show you where the activation energy would be. Remember, this is the additional energy from the reactants to the peak of the graph up to 80. That would be, this portion here would be the EA, the activation energy. Okay, it's just so you can get a visual for what it looks like on the graph. Okay, but moving forward, the very last question for number 2C asks, is the reaction above exothermic or endothermic? Hopefully you were able to identify that it's exothermic, and the reason is that the delta H, or the change in enthalpy, was a negative value, which shows that the potential energy of the products was less than the potential energy of the reactants, meaning the reaction released heat energy to the surroundings. Okay, sorry, I can't really type. Okay, there we go. So I'll make that a little bit bigger so you can see. I'll put it in red so we know it's our final answer. And that concludes the discussion for number 2A, 2B, and 2C for the potential energy diagram practice portion of the Day 35 handout. Thank you for listening.